Hello, everybody. I'm Patrick Chenezon. Thanks for coming here for this tech talk about XML11. So I met Arno Puder at Java 1 2 weeks ago, and I was presenting Google Web Toolkit on the booth there. And he started asking me very pointed questions about the compiler we were using and whether we were going from source or from bytecode. And then after a while, I realized there was no point into giving him a demo, so he gave me a demo of his project called XML11, which is a remoting protocol for AWT applications. So I was really flabbergasted by the demo. It's very impressive. And when he talked to me about the techniques of compilation from Java bytecode to JavaScript that he had been using in his project, I thought it would be interesting for him to come here, explain us at Google what he's been doing. So Arno is assistant professor at San Francisco State University, and he's going to talk about his project called XML11. This talk is going to be public. It's going to be videotaped and pushed on Google Video. Okay, so Arno, I'll let you speak.
So thank you very much for the invitation. I'm really happy to be here, especially in Building 42. You know, I'm a professor up at SF State, and every class I teach, whenever I need a constant, I usually use 42. And it takes about 2 or 3 weeks into the semester when one student finally comes up and says, Professor Puder, what's with the 42? You know? So I'm very happy to be in Building 42, and as Petra already mentioned, I'm going to give a tech talk on a project that I started about a couple of years ago called XML11, and I will explain the acronym a little bit later in my talk. But as already Patrick pointed out, the XML11 project has some relevance or some overlap with the Google Web Toolkit that was released a couple of weeks ago. And that's also how I ended up having these questions to Patrick. Anyways, first of all, I would like to introduce who we are. I mean, it's an open source project, so there are only just a bunch of Germans. I guess you have figured that one out by now from my accent. So I have 2 buddies in Germany who have been hacking on this in their pastime. We have one colleague here, Li Jin, in the audience. We are kind of thinking of some innovative open source dual licensing models for just emerging open source projects. So if you're interested in that, you can talk to Lei about this. We host XML11 at SourceForge. It's under the GPL license completely. So there's, unlike the GWT, where the compiler, cross-compiler is proprietary, we have everything in open source. And well, for the rest of this talk, I just want to give you a brief overview on what is XML11. Now, I would imagine that in this audience, people have a bit more broader background, and these are my generic slides. I'm going to walk through the first few slides a bit more quickly so we can save some time. Brief history of Ajax, asynchronous JavaScript and XML. So JavaScript has been around in browsers since the beginnings almost, but no one actually has used it. And I guess it was last year that you guys came up with Google Maps, or some company in Tasmania, I understand. And I guess people took notice and were really surprised at what you could do inside the browser. And then one gentleman, Jesse Garrett, he came up with the acronym Ajax, and basically kind of coining a new kind of web application paradigm. And the premise is that you're trying to develop web applications that make only use of the lowest common denominator. So why does Google Maps not use a Java applet? Well, because there are lots of Explorer users out there who don't have an applet installed. So what is the lowest common denominator? Well, JavaScript, some XML objects inside the browser. So that's basically the foundation of Ajax. Now, there's been a lot of hype around Ajax. And if you've been at Java 1, I mean, actually, I counted, there were like over 24 presentations, tutorials, seminars on Ajax. So it's really going off like a rocket right now, and everyone is interested in it. Another thing is that earlier this year, IBM launched the so-called Open Ajax Alliance. And all the heavyweights, including Google, of course, is member of this consortia. And funny enough, IBM has also invited us to participate in this alliance. So we're also a member of the Open Ajax Alliance. A quick technical background on Ajax. So on the left-hand side, you see the traditional web application. So time goes from top to bottom. You have your web browser on the left-hand side. You have the web server on the right side. And it's basically the fill out the form, push the submit button, wait for the response kind of paradigm. So you fill out your form. You click the submit button. It is being sent to the web server. You do whatever processing you have to do on the back end, and then eventually get some response back. Now those black heavy bars that I have marked on the timeline indicate user activity. And what you can see on the left-hand side is, of course, that the user has a lot of periods of time where the user cannot do anything, where the user is just simply waiting for the hourglass to go away and for the response to come back from the server. Now Ajax changed it a little bit. They push functionality, they push business logic into the browser. And they have asynchronous calls to the back-end server to do all the communication that is necessary for whatever application you're doing. But as you can see, is that the user experiences the application quite differently. So now all of a sudden you have like almost like a very highly interactive interface that almost rivals the desktop interface. And there are some analysts who predict that, that Ajax eventually is going to lead, or the browser eventually is going to become the next desktop. Right? Who cares about the operating system? You can just put everything inside the browser. And there are some really impressive Ajax demos that just mimic complete windowing systems inside a browser. So what is then the problem of doing Ajax? I mean, why is it not so simple? Well, there are a bunch of things. First of all, JavaScript is a prototype-based language. You know, everyone knows about object orientation, but only few people know about prototype-based programming. So if you want to do something like inheritance, like polymorphism, actually that is not so simple. And it's more like you have to follow certain conventions to implement features that are known from other languages like C++ and Java. JavaScript is not static type checked. So many errors only are surfaced and show up during runtime, which certainly makes debugging a great pleasure. There are hardly any IDEs out there. It's really a pain of writing JavaScript. But I think, in my mind, the biggest problem of Ajax is cross-browser concerns. And to point that out, I have to come back to this notion of lowest common denominator. Only use what is out there. Now, of course, you cannot tell everyone to use a certain browser. I mean, we should have different kinds of browsers. But it's incredibly difficult to write Ajax code or write JavaScript code that runs cross-platform, that runs equally well in Firefox as in Explorer. And one little example here, just of many, many little things that you have to deal with if you write Ajax applications, I have on the bottom of the slide here. And what I'm showing you here is imagine a hierarchy of panels. And imagine the user clicks on the innermost nested panel. Now, in which order is that mouse click offered to those panels? Well, on the left-hand side, that's the way how Explorer is doing it, is called event bubbling. And that basically means that the mouse click is propagated from the innermost nested panel to the outermost panel. Mozilla and Firefox are doing the other way around. So even though you click on the innermost nested panel, the mouse click is first offered to the outermost panel. And that's called event capturing. So imagine if you are knowledgeable in Explorer and you write your Ajax application, everything works fine. You try to run your application in Firefox and it doesn't work anymore. So you can imagine that you spend lots of happy hours debugging and trying to find out what the heck is going wrong here. So anyway, so I guess you get a good idea that Ajax development is not as simple as it may seem. Now, there are lots of toolkits out there, both commercial and open source, that offer you rich JavaScript libraries that help you to deal with Ajax development. And I guess with XML11, the Google Web Toolkit, and also this company called Morphic, that I might say a few words about later, have taken a different approach. And to motivate that, let's go on the next slide here. And I just want to motivate you or explain to you, why do people no longer write programs in assembler? Well, it's a major pain to write in assembler, right? Who in their right mind would write an application, a heavyweight application in assembler? Everyone is using a high-level programming language like C++ or Java. And then you have tools, a tool that compiles from this high-level language down to assembler. So ideally, when you develop your application, when you debug your application, you never get to see the underlying assembly. Also note that if you have, for example, a C++ program, by taking the appropriate compiler, you can create code for different platforms. So you no longer have to worry about differences of Intel assembly or MIPS assembly or Spark assembly. You can just simply rely on the tool to take care of that. Now, the way we see it, and that's the premise of XML11, likewise also with the Google Web Toolkit and Morphic, is that, that JavaScript is the assembly of the web. So if at all possible, you don't really want to see that, right? And what would be much nicer if you could actually write your web application in Java. And then you, again, have some kind of cross-compiler that cross-compiles from Java to JavaScript. So just like as a C++ programmer, you never get to see the assembly, as a web developer, you never get to see the underlying JavaScript. Now, that is kind of the overall common theme between XML11, the Google Web Toolkit, and also Morphic. But XML11 has a few other little things in there that I want to first talk about before I actually talk about the code migration framework. So, and also to explain to you why this project is called XML11, let's just take a quick look back in history. And I look in the audience, and you look all old enough to be familiar with the X Windows system, maybe except you there in the front here. But the rest of you, I suppose you have heard about the X Windows protocol or the X11 protocol. It's basically a client-server protocol, and the way it works is that you have the X server, that's where the user sits. That's just like a graphical terminal where the user interacts with the application. But the application is running on a different host in the network, and the X protocol basically defines how client and server talk to each other. So the X11 protocol, just to point that out, does not know anything about widgets. So there is no concept of buttons or list boxes or scroll bars in the X protocol. If an application wants to do a button, they have to do it manually. And that also explains why X applications typically have a very different look and feel, because every application has different options of how they want to draw a button. Now, when you think about it, now when you kind of just abstract away, again, computer science is a lot about abstracting away from things and trying to find common themes. The X server is a generic client, just like a web browser is a generic client that offers you access to remote applications. So when you make that comparison, you might say that the X server as well as a web browser are simply simple examples of generic clients. And here on the slide, I have a few different comparisons that kind of compare those to different technologies. So granularity, well, as I already mentioned, X server only knows about pixels and lines and rectangles and circles and so forth, whereas the web browser actually has a fairly rich set of widgets. Execution platform, well, the X server is a pure dumb terminal, so you cannot execute any code inside the X server. Whereas with a web browser, you do have Java, JavaScript, depending on your plugins or Flash. Now again, like for Ajax development, we're only interested in JavaScript, but I just wanted to point out that a web browser can also execute business logic, which you cannot do with the X server. Well, the protocol, you have an asynchronous protocol for X Windows, you have a synchronous HTTP-based protocol in case of a web browser. Well, platforms, there are many different implementations of the X protocol on the server side. And let me just point out one, WeirdX, that I'm going to come back to in a little bit when I give you the first demo. And WeirdX is actually an implementation of an X server in Java. Okay, so it's a Java application. You can run anywhere where you have Java. And when you run it, you have like, it pops open a window, and that window is your X server. So you can remotely connect to your X server and run X applications. So now the motivation for our project is that you know, it's kind of a tribute to the X protocol. So we call XML11 an abstract windowing protocol because it's in its essence very similar to the X protocol. So it's also an asynchronous protocol between a client and a server. And because of that fact, we dubbed it XML11. So it's XML because the protocol is XML-based, but the 11 is kind of an homage, a tribute to the X Windows protocol. Now, of course, there are some differences. XML11 is not about pixels, it's not about rectangles, but it's about buttons, list boxes, and so forth. And of course, there's also a code migration framework that I will explain in my second half of my presentation. So, oops, sorry. The informational model. To most people, it comes actually as a surprise what kind of control you have inside a browser. I mean, most people, at least who are a little bit techy, have done HTML pages. You know, like you take an editor, your favorite editor, and you just hack up some HTML. But some people, at least, don't realize that you can do the same thing in JavaScript by doing DOM manipulations, the document object model. And what I've shown you on this slide here is on the top of this line, I've given you a little bit of HTML snippet, and the very top shows you the graphical representation of this hierarchy of panels. But what I show you on the bottom here is actually a little bit of JavaScript code that adds one more panel to this hierarchy here. So basically what you see here is that, what am I doing here? I'm appending something to element 3. So if you look at panel with ID 3, the little bit of JavaScript code I'm showing you here actually shows how dynamically at runtime you modify your HTML page by appending a new panel as a child to this one called ID 3. And just as you can append something, you can also remove something. So you can very dynamically modify your HTML page. So it's not only about loading static HTML pages into your browser, but you can actually, at runtime, modify your HTML. And as you can imagine, the protocol engine of XML11 is doing exactly that. So the protocol engine that runs inside the browser of XML11 is being told, okay, I want to have a button at this location. And then we do this kind of DOM manipulation to actually place the button at the appropriate location. So then the protocol, as already mentioned, is XML-based. And as a matter of fact, it's actually an asynchronous protocol. So on this slide here, I'm showing you two little PDUs. So on the top, you see one PDU that is traveling from the application, from the server to the client, to the web browser. And what you can see in that XML, it basically shows you the creation of two user interface elements, one label and one button, one input field. And that's kind of the markup you see on the wire. That's the protocol you would see on the wire if you would observe XML11 in action. And you can see it's, those of you who have some familiarity with Zool, XUL from Netscape. So basically, it's, we've taken a bit of Zool, but then we've created some XML around it that allows us dynamically to create individual widgets and remove them. On the bottom, you see some other XML that shows you what happens when the user starts interacting with the user interface. So for example, if the user clicks on a button, then what would happen is that the protocol engine running inside the browser would then send a PDU back to the application that then processes this event, and then depending on what has to be done, sends more updates to the browser. Now, one thing I already want to mention now, point out here is the fact that XML11 is an asynchronous protocol. Now, all of this is piggybacked onto HTTP, which is a synchronous protocol. So the question is, how do we actually implement an asynchronous protocol on top of a synchronous protocol? If you imagine if you have a button inside your web browser, if you click the button, I mean, that's easy, right? I mean, you can just simply at that very moment issue an HTTP request and send it over to the server. But what happens if you have something happening on the application side, on the server side, and you need to communicate that immediately back to the web browser? Well, what we do is we use a technique called deferred reply. So basically what the protocol engine inside the web browser is doing, it is issuing an HTTP request. When the server receives the request, it simply does not respond. It just stalls, it defers the response until there's something to be sent back to the application. So by keeping an HTTP connection open, we can at any point in time send back PDUs from the application to the web browser. That's how we achieve this asynchronous protocol. So on this slide here, I have just a very broad top-level overview on some of the XML11 elements that we have in our protocol. And already pointed out, we have all the standard things that you would find in Zool, so buttons, labels, input fields, and so forth. And that's where kind of we differ then from Zool. We also then have XML tags for dynamically creating and destroying widgets. We have a code tag that I will explain a little bit later that allows us to migrate code to inside the browser. We have events for communicating events from the browser back to the application. We have new value as a tag, which basically just means model update. So whenever the user populates any fields inside the user interface, then these are being sent back to the application as model updates. So basically, I want to start with the first demo now. And what you will see here is basically the setup here. So I have a web browser, and of course, my web browser of choice is Firefox. Needless to say. And the XML11 broker acts like a web server. So when you see the XML protocol, it is actually piggybacked over HTTP. So the XML11 broker acts like a web server to the outside world. But then what we do is we have the application running inside the XML11 broker. And here's one big difference from the way what we do in XML11 to what the Google Web Toolkit is doing. The Google Web Toolkit has its own widget library. So there's a Google button, a Google list box, a Google whatever. Now what we have done in XML11, we have simply written a replacement of the abstract windowing toolkit, the AWT. That means you can write your web application as a standard AWT application. And just simply by swapping the AWT toolkit underneath, you turn it from a desktop application to a web application. You don't even have to recompile your application. And let me show you how this works. So what I'm going to do first is I'm going to go into Eclipse, and I'm going to run a little AWT application. So what you see now is that's nothing to do with XML11. That's just like a little demo application that we have written. And we call it layout demo because one of our earlier examples where we just show different layout mechanisms, flow layout, grid back layout, and so forth. But you already see a bunch of different widgets here. You have text areas, you have input fields, labels, you have an image panel that has an overloaded paint method to draw this little XML11 logo. You have buttons. If you type something in here, and if you click something here, if you click on the dump button, then it will just show up in this field down here. Also, one thing you should notice is these asynchronous updates. So if you look down here, you will see that the free memory is updated asynchronously. So I'm not touching the user interface, but it keeps on updating the time and the available memory, which is a common thing that happens for desktop applications. Okay, let me exit this thing here. What I'm going to do next is I'm going to run the XML11 broker. And when I do that, of course, at first, nothing happens. I switch to Firefox, which I haven't launched yet. So I'm launching Firefox now, and we have some entry pages that also shows you the kind of applications that we have deployed on the server. Now, since everything is locally, I just go to localhost. And then what I'm going to do is I'm going to click on layout demo, but now running under XML11. Now, the same class file that I use for running the desktop application is now being launched inside the XML11 server. So basically, when the application starts to run, when it starts to build up its user interface, our replacement AWT toolkit interfaces that, creates those XML11 PDUs, and sends them via asynchronous update to the browser. The protocol engine inside the browser then interprets the XML and creates via DOM manipulations that user interface. Now, first thing I hope you notice is that there are actually these asynchronous updates down here. See that? So I'm not touching the user interface, but as the application is running in the background and it's updating its own user interface, we push these changes out to the application. And of course, as you might expect, it behaves the same way. So I can just type something in here. I can click something. I have the dump button. If I click on it, it will just behave exactly as the desktop application. Now, what you see here is completely in JavaScript. No plugins necessary. It runs equally well in all major browsers. Now, I wanted to show you another demo. And let me switch back to my slides here. And that's what I've shown you so far. So I've shown you our little demo application that is running inside XML11. Remember when I talked about WeirdX, and I said WeirdX is a Java implementation of an X server. Now guess what? WeirdX is also only making use of AWT. So the internal implementation of WeirdX is using AWT. So why not run WeirdX inside XML11? So what I'm going to show you now is the following picture here. So actually XML11 now acts as a protocol bridge. So what happens now in the next demo is that I'm going to launch WeirdX just as I launch this little demo application that I've just shown you. But then what I'm going to do is I'm going to launch different X Windows applications. And then they will use the X protocol to talk to WeirdX. And then via the XML11 mechanism, it's going to be pushed out into the browser. So let me show you how that looks like. So what I'm going to do first is, oops, I'm going back to Eclipse. I'm relaunching the server. I'm going back to the entry page. I'm selecting WeirdX now. Now when I launch WeirdX, and let's just take a second here for it to launch up. What you will see is just a big black blob. What is that? Well, that's the X server background image. You don't see anything yet because I have not yet launched any X applications. So what I'm going to do next is Xcalc, the good old X Windows application. Now when I hit enter here, let's first of all notice the command line that I use here. So I call Xcalc, I use the -display option to redirect the X protocol to the WeirdX instance running inside of XML11. So when I push the enter key, now it will take a little while, but carefully notice how the application is built up. You can see how all the images are being loaded as little image files into the browser. But guess what? I can actually interact with the application. So I can go inside of here, and you can see the mouse moves are interpreted. And you know, of course, it's a little bit slower since we have this whole turnaround from the browser to the X application. But I can do my favorite equation here. Another little gimmick here. I suppose all of you know this little guy, XIs. So that's just another X application that is being run in parallel to other applications. Now, if I, one second, if I kill the application here, then of course XIs also disappears. If I kill Xcalc, then dynamically we also remove all the widgets. You have a question over there?
Yeah. How is it doing the drawing for the graphics for the XIs?
Okay. Okay, so the question was, how is the drawing actually happening for the XIs? I'm being told to repeat every question here for the web audience. The way it works is that, well, imagine what WeirdX is doing. They have a custom panel that has an overloaded paint method. And when you have incoming X requests, they do like all kinds of draws. So they have like a drawing of circles and everything. What XML11 is doing is just simply capturing a PNG image of the whole panel when it's done drawing. So what we push out to the web server, to the browser, sorry, is a PNG image of the final thing that's being rendered. So actually, if you let me maybe call XIs again. If you pay close attention to the bottom in the status bar of Firefox, you can actually see when I move the mouse, you can see how things are being reloaded. But what we are reloading is actually new PNG images that have the final rendered image inside the PNG. Question answered? So let me kill this here. Go back. So just to wrap up the demo that I've just shown you, that's basically what happens here with the XIs example. So XIs is happily running, and then the user moves the mouse. Via JavaScript events, we interface that. We create the PDU you see on the left side, on the top left side. That just basically, if you just read the XML in there, you can see it's an event, it's a mouse click, it's that position. That is being sent via HTTP to the XML11 broker that then puts the event as an AWT event into the application queue. Then WeirdX is picking up the event by calling action performed of a mouse listener. It is reacting to the mouse event. It is sending via the X protocol something to XEyes. Now XEyes responds by sending back via the X protocol, okay, now repaint the eyes to look in this direction. WeirdX is redrawing its user interface. We capture that in XML11 via our own replacement AWT toolkit, and that is being pushed out via these asynchronous updates to the browser as a PNG image. So that's kind of the round trip that you saw so far in terms of the XEyes here. Now, this is kind of all nice and cute, but oh, actually, there's one more thing. So what I've shown you so far are just standard widgets. So we just have replaced widgets from the AWT toolkit. So buttons, panels in this case. What I'm going to show you next, actually, XML11 has a plugin architecture. It's actually built around what we call a microkernel architecture. So we can actually plug in new functionality into XML11. And that comes in handy when, for example, you want to extend XML11 for new custom widgets. And basically, when you think about it, like it's very common for an application to have a custom widget, so something that does something special. And normally, you have a native implementation, so a native implementation done based on AWT running on the desktop. Now, for XML11, what you have to do is you have to create two pieces to kind of map this custom image to XML11. You have to have, first of all, a server-side and a client-side implementation of this widget. The server-side, written in Java, basically creates the PDUs and accepts incoming PDUs from the browser. And the client side, written in JavaScript, likewise interprets the XML11 PDUs. Now, for a little demo, I want to show you another little demo here. And basically, before I run XML11, I just want to show you the desktop application. So what I show you now is just a desktop application. It's one of my toy projects. I happen to live in San Francisco, and I'm also a movie buff. So I've been working on a database that shows you movie locations for movies. So if you have your favorite movie, then you can click on the movie and you can see locations where certain scenes of the movie have been made. Now, since I'm lazy, I created a custom widget here, and I stole something from you guys again. Well, not steal, I shouldn't say that. But I used Google Maps. And I mean, that in itself is kind of a neat little thing. How can we integrate Google Maps into a desktop application? I'm not going to talk about this here. The point is that what you see in the top right corner is Google Maps, and it's a custom widget that I have integrated into my own application. So if this thing behaves like Google Maps here. Now, if I click on one movie here, The Game, Michael Douglas, nice movie, right? You get a little description down here on the bottom, but notice that you also have these markers here. And for this movie, I only have 2 locations. If you click on the location, it shows you a little picture and the address. And I'm still working on the application, so you can add some more comments. You can say, well, that's where Michael Douglas was chased down on Stockton Street, and But again, the point here is that I have an application that uses a custom widget. Now, what if I want to run the same application now under XML11? Well, I have to create a wrap. I have to create a plugin for Google Maps. And that's exactly what we have done. And the nice thing is, and you can imagine why we've chosen Google Maps, is because we already have the implementation in JavaScript. I mean, you guys have done the implementation with JavaScript. So creating the JavaScript side was very easy in that case. And that's why we've chosen this example. So what I'm going to do now is I'm going to run again XML11. And I go back to my browser. And what I'm going to do now is just simply launch the same application, same class files. I did not recompile anything, and run it inside Firefox. And what should come as no big surprise, it looks exactly the same as the desktop application. This is done completely in JavaScript. No Flash or applet plugins here. Again, you have Google Maps, of course, since it's running inside a browser now, it behaves like it should behave. And if you click on the movie, then you end up having also these markers here where you can just simply click on it and you get the same thing as before. So basically, going back to my presentation. So what I've shown you here is, or basically, you know, like the way things work is, on this slide here, I show you like the sequence of events. So imagine like the server-side application is placing a marker. Like if you click on the game and you have these two markers, so what kind of code will you see executed inside the browser? Well, on the top here, the Java code, you will see something like this. So we have created Java wrappers, Java classes wrappers for Google Maps. So you can use Java API to, you know, create these overlays, create these markers, and define longitude, latitude. And that's what you see in the top box here. So basically just, okay, here I want to place a G point at these coordinates. Now, the plugin that we have created for XML11, of course, replaces that API. It is the same API, but it replaces the API, the implementation of the API, by creating the XML11 PDU that you see here in the middle of the slide. And you can see it basically contains the same arguments, the same parameters that also have been used inside the Java code. But upon receiving that PDU on the client side inside the browser, then we use on the bottom a bit of JavaScript that actually then uses Google Maps API to also place that marker. So when you think about it, what we actually created is not only a plugin architecture for a microkernel approach, but we also have created a dynamic protocol extension, right? The protocol changes depending on the plugins. I mean, this PDU only makes sense if we have the Google Maps plugin running. So we can dynamically extend the protocol at runtime depending on what kind of plugins, what kind of custom widgets we have inside our broker. Any questions so far? So what I've shown you up to now actually is kind of nifty and it uses lots of JavaScript, as you can imagine. But you know what? For me, that's not Ajax. I'm still missing one key ingredient for Ajax, namely pushing out business logic into the browser. What I've done so far only is I'm still running the application on the server side, right? And via the AWT replacement, I'm interfacing with the, whatever the application is doing. I'm creating these XML11 PDUs. They're being sent to the browser, interpreted, but it's just like the X server, right? X server is also a dumb terminal that is only responding to requests coming from a remote X application. So what I'm still missing in this Ajax equation is code migration. How can I actually migrate business logic from the server side into the browser? And as already mentioned in the beginning of my presentation, we have taken the approach of that we see, okay, JavaScript is ugly. It's like the assembler of the web. So we have created a cross-compiler that cross-compiles from Java to JavaScript. Now, I took a look at Morphic. I took a look at the Google Web Toolkit, and in both cases, you guys and Morphic are actually using Java source code to cross-compile to JavaScript. Of course, if you have enough resources, then you can do that. And it's, you know, compiler construction is a difficult topic, and it's not something taken easily. And actually, I was also interested to find out that the Google Web Toolkit does not yet support Java 5 features. So generics are still missing. So you know, that tells you that obviously writing a full-fledged compiler is not an easy task. Now, being a poor academic, you know, what can you do if you don't have the resources to write your own big compiler? Well, we take a little shortcut. And, well, I kind of skipped over this code migration slide. You already mentioned that. And basically, you know, what I'm going to explain to you now is, I guess it's useful if I just quickly make a few comments about the Java virtual machine. And I guess we all have used it extensively, but only a few people actually know what's happening on the inside. So a Java virtual machine is well, almost like a little CPU, except that it's a stack-based machine. So you will not find registers. You will not find like an AX register or BX register like on the Intel CPU, but everything is being done via the stack. Now, the Java program is compiled by a Java compiler into bytecode. And what the Java virtual machine is actually executing is bytecode. Now, it's garbage collected, and I guess we all know that. Bytecode instructions are often very simple, sometimes quite complicated. For example, there is a bytecode instruction for a virtual method call. There is a bytecode instruction for instantiating a new object. So the whole garbage collecting thing and reference counting and everything that goes along with it is actually hidden inside the virtual machine. Now, having said that, like how do we do code migration in XML11? And basically, what we do is, we're taking a shortcut. We're not taking the source code of an application, but we do the heavy lifting, do a compiler, a Java compiler. And then we start from the class file. And there's actually a little sub-project that we dubbed XMLVM. XML again, because we, as you will see shortly, we're expressing the bytecode through XML, but VM for virtual machine. On the bottom, you see a very simple example that shows you how to add 11 to 31. And again, since the virtual machine is a stack-based machine, what you would see in bytecode is load constant 11, load constant 31. It's basically two push operations. So you push, and then I add, integer add, basically then pops off the last two arguments and then pushes the sum back onto the stack. There's a question in the back?
Yeah, why did you just use an XML representation rather than just interpreting bytecodes directly?
Okay, the question is, why have we chosen XML representation for the bytecode and not just taking the binary format? Well, actually, XMLVM has evolved out of another project, unit testing, functional testing for middleware. And the idea here is that we have a unit test case written in one language, in our case back then for CORBA, and we automatically create for another language, C++. And you will see then why XML is actually of benefit here. Actually, let me show you an example, end-to-end example on how this thing works, and then probably also your question will make a little bit more sense. Or you will hopefully see how we do, or why we do that. So what I show you now is, so here's a very simple Java class, right? What is it doing? Not a whole lot. It has one member called X. It has one method called add, one input argument, and all it's doing is simply adding the input, the actual parameter, to its member. Very, very simple. Now, what I'm going to show you on the next slide is, okay, first you run this little Java program through a Java compiler. You get a class file. Then we have our tool called XMLVM. And that creates XML out of the class file. So on the next slide, I'll show you this XML for this particular program here. Now, it looks a little bit clunky. It looks not very pleasant. But the point is, again, it's created by a tool, and you're not really supposed to look at it, except if you're sitting in my presentation here. Now, what you see in this XML, it's one for one, exactly the same content you will also find in a class file. So it's identical in terms of content. There's a bidirectional mapping between a class file and our XMLVM. And if you look carefully at this XML, you will find all the familiar things that you would expect to be present inside a class file. So you see the class declaration, class name, calc, you see the field X that I had in my source code, and of course you also see the method called add, having one one formal parameter of type int. But what you will also see is here in the code, this code tag. And what you see as children of the code tag is the bytecode that was created by the Java compiler. And it takes a little bit of time to actually read that, and I'm going to spare you exactly what is happening here, but you will see in the middle somewhere I add, right? I mean, this integer add. If you remember, that was what was class calc was doing. It was taking the actual parameter, adding it to a field. So you can imagine what happened before then, which is simply pushing the arguments onto the stack, and then I add is taking care of the addition, and then the put field, well, that's then pretty obvious, is saving then the result back into member variable X. Okay, so now we have this XML. So far, so good. What do we next? Well, again, we are pretty lazy, and what we do is okay, I have a few slides here that actually show how to execute the bytecode. I'm just going to run through this very quickly here because I suppose you guys know how a stack machine works. So, you know, what I show you on this slide here, I kind of single step through the bytecode. So load loads this pointer onto the stack, duplicates the last argument, get field retrieves the content of X, loads a constant onto the stack, then I add computes the sum, 42, and then put field saves it back to X. So I'll give you the slides so you can look at it a bit more carefully. So that's basically how the bytecode is executed by the virtual machine. Now coming back to what I was actually wanting to say is then what do we do with the XML? Okay, now we have an XML representation of the content of a class file. How do we go from here to JavaScript? Well, what we do is we just use XSLT. We use style sheets to create JavaScript. And what we do is we mimic the stack machine in JavaScript. So for example, the I-add instruction that I've shown you earlier, well, what does it do? It pops off the last two arguments of the stack, it computes the sum and pushes the sum back onto the stack. So what you see is here is a little snippet of XSLT, and what you see is a template. It matches whenever it sees I-add, and what you see in black color in this box is basically the JavaScript code that is being emitted whenever you see I-add in the XML. So we have two variables, actually a bunch of variables, stack, sp, op1, op2. So stack is just a JavaScript array. sp is another JavaScript variable with which we mimic the stack pointer. Op1, op2 are just simply temporary variables. So a pre-decrement simulates a pop instruction, a post increment simulates a push instruction, and you can see how this piece of code works, right? Very simple, very plain. So actually, for the last demo, I just want to show you, that's also the demo we happen to have on the XML11.org homepage. So once again, oh, I think I made a mistake now. Hold on a second. I think I started it twice now. Oh, it should be okay. So oops, sorry. I'm starting the XML11 broker again. I go back to, did I kill the web browser? I go back to the entry page. And actually here the main page overview. That's also what you will see when you go to XML11.org. And takes a little while. Now, same concept again. So first we have written an AWT application. On the left side, the screenshot, you see like a screenshot of that desktop application. And what you can see, it's a calculator. Right? This is a very primitive calculator that is doing a few things, allows different operations. But what you see on the right-hand side is now the Ajax version, cross-compiled to JavaScript using the technology that I've shown you on the last few slides. So before well, actually I can interact with this thing here. So 21 times 2 equals 42. Now, if you can click here, so we have like a link. So this is the Java code. That's the Java code that a developer wrote to implement this calculator. And it has like what you would expect. It's using AWT buttons and different layout managers, and it has an action performed that whenever you click on something, you're being notified, and standard Java stuff. But the point is, again, there's a lot of skill set for this kind of knowledge out there in the industry. Right? Lots of people know how to write Java applications. Now, once you have this Java code, you just take our tool, and let me show you what the JavaScript version looks like. Well, remember, JavaScript is the assembly of the web. You're not supposed to look at it. You're not supposed to actually try to read it. But the point is, what you see here is semantically equivalent to the Java program I showed you before. And it's only using JavaScript API. It's only using DOM manipulations to do whatever it has to do. So that's where, it's also basically the gist of the Google Web Toolkit, as well as Morphic. So if I go back to my presentation here. So actually on the next slide here, I've just shown you, this is kind of like explaining the mapping here. So it's kind of a little bit more readable, but you can see how individual bytecode instructions are being mapped to a bunch of JavaScript primitives. And we just simply mimic the stack inside of JavaScript. So you can see on the top you have a variable called stack that is being initialized as an array of size 3. So that's a variable that we use to mimic the stack. Now, I have a few more slides, but I'm just going to quickly go over it. And again, this is like my generic slide set. And if you're interested in some performance measurements and overhead measurements that we have done, I can do that offline. But actually, I wanted to just quickly go to this slide here. So I have taken a little bit of a closer look at the Google Web Toolkit. And at least, on first glance, here's kind of my nutshell summary of how XML11 differs in what you guys are doing with your web toolkit. Now, the first thing is the philosophy. With the Google Web Toolkit, you view applications as web applications. And it might sound awkward, but I know that the GWT puts a lot of emphasis on things like history, bookmarking, that you can place a bookmark into an application, that you can use the back button to kind of go back to where you were. Well, that's all good and fine, but remember that in XML11, we have more of a desktop approach, a desktop philosophy to the application. We have asynchronous updates. Remember those timestamps, that kind of asynchronously keep on updating every half second. How do you place a bookmark into that? I don't know. So we don't have a bookmark feature. Cross-compiler. So both Morphic and the GWT are using cross-compilers that start on source code level. And I don't know for Morphic, but I know for sure for the GWT, you only support Java 1.4. The beauty of starting with the bytecode is when they did Java 5, they made lots of changes to the Java language, but they made no changes to the bytecode level. So when Java 5 came out, we just simply supported it like that. We had no problems with that. Widget toolkit. Well, our philosophy is take an existing toolkit. So don't invent your own toolkit as, I'm sorry to say, Google has done, but use an existing toolkit like AWT, like Swing, like SWT. There's a lot of skill set out there, a lot of tools out there. Imagine, for example, in Eclipse, the visual editor project. I mean, you can leverage all these tools and write all these applications if you manage to write your toolkit in such a way that it replaces a standard toolkit. Now, debugging, here I'm not quite, I try to understand exactly what's happening here, but what I understand of Google Web Toolkit, it makes heavy use of hooks of Internet Explorer, which means that people who want to use open source, who want to use Linux, who want to use Firefox, are a bit on the downside for that. Now, since we are using kind of a native approach, we have the AWT, you can use just native debuggers. There's actually no browser that you need to launch in order to debug an XML11 application. You can just use whatever you have been using in the past to debug your desktop application. That's kind of the top-level nutshell view on how I place ourselves in comparison to at least the Google Web Toolkit. Now, of course, we are still a very young, very small open source project, and there are still a gazillion of things to do. Right now, the most work actually we put into XMLVM. And we have things that we are just implementing now is dynamic loading of classes. So basically, that what eventually is going to happen is that what we have inside the browser becomes its own virtual machine. Just like a class loader in Java VM is loading classes on demand, we actually are also able to load classes on demand. It also I've seen on some comments in discussion boards on GWT, one downside of your toolkit that you have to compile everything statically, and then basically you just have to load everything in one big blob into the browser. So we actually mimic more the semantics of, or the behavior rather, of the Java virtual machine by dynamically loading classes only when they're needed. There's stuff like, I mean, I don't want to go into too many details here, but we have an idea of implicit middleware, so there's no need for explicitly writing RPCs or creating interfaces. So we also use XMLVM to introspect signatures of remote operations and then automatically create proxies to do a remote client-server communication. We still have one problem. JavaScript, as primitive as it may seem, but believe it or not, it doesn't have a go-to statement. Now, why is that a problem? Well, it's a problem because Java bytecode is using go-tos. I've done a quick hack to get around that for now, and it's a combination of an endless loop with a switch statement. Makes for a nice final exam question in one of my classes, but that's not a general solution. If you have exceptions, catch blocks in there, this scheme is going to break. But luckily, there is a nice go-to elimination algorithm by a gentleman called Ramshaw, already done 25 years ago. So we're just in the process of implementing that. People optimization, so you can do quite a bit of optimization on the generated JavaScript, especially if you look at the push and pop behavior. Sometimes you push something, immediately pop it again in the next statement. So there's no need for doing that. You can do some very intelligent little peephole optimizations on that. One thing we also haven't done yet is retain semantics of numeric type operators. So like the plus operator, if you carefully noticed the IAD instruction, it's actually not quite true. I mapped IAD to a JavaScript plus, which is not correct because Java has different semantics when it comes to integer addition. But that can be taken care of a little wrapper library that simply is calling an IAD JavaScript function that mimics the semantics of the Java add operator. Well, for XML11, the to-do items are broader support of AWT. There are still a few widgets that we don't support. And of course, AWT is kind of antiquated, but at least people know how it works, and we had some documentation on it. But obviously, it would be better to also support different toolkits like SWT or even Swing. One little project that one of my students has just begun to work on. Remember when I told you WeirdX is like an X server written, or at least in Java? I guess you also know VNC, this remote desktop protocol. Actually, there's also a VNC viewer implemented in Java using AWT. So, but unfortunately, they're using a few things that we don't support yet. So one of my students is going off in that direction, trying to make VNC run inside of XML11. So the nice thing is you could connect to a remote VNC desktop without having to have a VNC installation on your desktop. So I think even like without the code migration, XML11 is kind of a very useful little tool. Well, the future, I have done a lot of work in the OMG, so I'm very familiar with CORBA and MDA and all those kind of things. Actually, we also have a little prototype that is doing the same thing, what I've shown you with Java, but using .NET's intermediate language. You probably know that IL is also, is basically the bytecode equivalent in .NET for what you have on the Java side. So actually we have a Hello World running that is using the same technology. It's using, it's taking a .exe file that came out of a C# compiler and is creating the same XMLVM. But as one little project we're working on right now to create an MDA model, kind of to try to find commonalities between those two virtual machines, and try to come up with like a general meta model to cope with both these kind of worlds. So also another little benefit of using virtual machines rather than source code. Anyways, so that is also getting to the end of my presentation. So XML11, again, on the outside is an abstract windowing protocol inspired by the X protocol. We have a code migration framework based on XMLVM, which is just a XML representation of Java class files. And the homepage, you can download some more documentation. I have published, that's my main business. I don't make money. I just publish papers and try to inspire, the better or the worse, other people. But some publications I have done on this topic. And I would like to thank you for your attention. If you have any other questions, I'd be happy to answer them now.
Did you try your compiler with Java application using generics?
The question is, have we tried our compiler with an application using generics? No, we have not. But I know that the Java bytecode has not changed, so I can guarantee you it will work.
So where does, like, let's say you're using AWT, where is all of that, Java.AWT packages, where are they coming from? Are they just all loaded in? Or?
Okay, so the question is, where do the AWT packages come from? Well, okay, I can show you, I like to touch the keyboard, so let me show you in Eclipse where this is here. Actually, let me go to the Eclipse launch configuration for XML11. And look at this argument here. It's a little bit small, but there is a system property called awt.toolkit. And you can give it your own class. And this happens to be the kind of main interface that is used as a factory for creating things like buttons and list boxes. So by passing this property to the JVM, you make sure that whenever an application is using AWT, java.awt.button is being redirected to your class. Yes?
So what work is left to be done with Swing, since most of Swing sits on top of it?
Okay, yes, that's a good point. Technically, Swing is built on top of AWT. The thing is that they draw everything, like they just use for drawing buttons. We're not quite there yet. We have done some image capturing that works for WeirdX, and we're getting closer to VNC, but Swing is doing some funky stuff in there, and we're not quite there yet. But to be honest, I think it would actually be worthwhile to do a different kind of reimplementation that does not rely on redrawing everything, but is mapping a Swing button also to an HTML button. Yes?
So, one of the things I was sort of hoping for was that somewhere in here that you would do for user interfaces what HTML did for documents, which is separate the concerns of document structure from layout. So
finding your applications, you have like GUI editors. You can drag and drop your buttons into the application. So I don't know if your question is going in that direction.
So let me give you an example. If I have an HTML page and I make the browser's window narrower, everything gets reformatted.
Yes.
If I don't like 10-point font and I want to see 20-point font, I just set it and it all happens.
Yes. Okay, so
Try
that
with most desktop applications, the layout does not adjust, the field labels do not adjust, none of that stuff.
Well, okay, so the thing is that depends on the widget toolkit. So remember, AWT is a very old toolkit. Now, there are some layout managers, like Flow Layout, that do actually adapt to resizing of windows. And we managed to retain that semantics inside of our XML11 system. Now, if you talk about changing font sizes, AWT has no good support for that. It was one of those things that they added in Swing. It's called look and feel, so you can change the look and feel of an application. Now, I believe you can also mimic that, and you can kind of interface it the same way we have done with AWT, and then mimic the same behavior inside the browser, but we haven't done this yet. So I believe what you address, you're right. I mean, we haven't done it yet, but I believe we could do it if we just put enough resources. And then you can just use the standard tools for building GUIs. You have your GUI editors, and you can just drag and drop your buttons and your layout managers and just build the application declaratively.
Well, yeah, I guess I was hoping that the protocol was a declarative protocol, and so that the application author did not have detailed control over the layout.
Now, the examples that I've shown you very early on, if I go back to the slides here, I mean, you saw, and that might be the source of your question. Here in this example that I had very early on where I showed you an example. I mean, here you see absolute coordinates, right? You see, okay, put the label at position 0, 10. That is only because the layout manager we have used for writing the AWT application is making use of that kind of feature. If you use something like a flow layout, which again is adjusting its layout and dynamically, you would see like Zool elements, that kind of arrange logically, and put the button left to the label, that kind of thing. So it is possible, we just haven't pushed it that far yet.
How does this tool get compared to XIML and UIML and all the user interface markup languages that kind of have an abstract notation for the UI but can be interpreted in whatever other language?
Yeah, well, I guess so the question is how does XML11 compare to other markup languages? And let me just take Zool as an example here from Netscape. They use Zool for creating all the user interfaces in Netscape and also in Firefox now. Now Zool describes a static page, just like HTML describes a static page. So we have that as a subset of XML11. So we also have markup that defines a button, that defines a label, as you can see here. But what you will not find in Zool, for example, is what you see on this slide here, create. That at runtime, dynamically, you can create, you can change the user interface. So that's where I see the main difference between us and those static UI markup languages. It's a protocol, it's not just a static description page language, but it's actually a protocol. Any other questions? Yes?
Yeah, something I didn't understand in the various demonstrations is when you're showing the X11 server implementation, the server is running, then you access the application proxy from the browser. On the little calculator example where you have compiled with JavaScript, it's all static on the web page. Mm-hmm. So do you have an option that you give to your compiler about what you compile with the browser or not? What are the limitations here?
Okay.
Jar,
okay.
All of business logic and I see the browser would that work?
The question is, I've given some examples that left all the code on the server. I showed some examples that put all the code inside the client. There is a configuration file. So for each application that you have, there is a configuration file, and you can specify on class level which classes should stay on the server, which classes should be migrated to the client. Now, what happens if a piece of code on the client is making invocation to a piece of code that is supposed to remain on the server? Our idea is, and I put it on the last slide, is what we call it implicit middleware. So implicitly, we kind of move the middleware in between. We haven't done this yet. We can do that by static analyzing of the signatures that we can see what is being called, and then we can create proxies for that. And we plan on automatically creating proxy that creates SOAP messages. But we already have this configuration file that allows you to specify on class level, which classes should go where. But right now, for all the demos, the constraint is that if you migrate something, it has to be autonomous. So if that is making use of some remote database, for example, that we cannot do yet. Another question?
If we just talk about the code part of it, not the UI part of it,
yes.
Then what we have right now is bytecode that gets translated to XML, then it goes through XSLT, and then JavaScript.
Yes.
So is there a reason for this 4-step process instead of just bytecode to JavaScript as like,
okay, the question is, why do we have this XML step in between? And as I mentioned earlier, actually we came from a different direction with that project. We were looking at functional testing of middleware. And actually we also have style sheets that take the same XMLVM and map it to C++. Now that doesn't do us any good for Ajax applications, right? But it is actually quite nice if you want to have one test case and automatically cross-compile it to different languages. Like in Corba, I did a lot of Corba work, and then you have like different language bindings, and you don't want to rewrite the same test case in 10 different languages. So we wrote it only once in Java, and then used XSLT to just simply create the same test case for different languages. So kind of that's a bit of the history where XMLVM came from. But in the long run, to be honest, I think I still want to retain this kind of several-step tooling, especially when we look at .NET, right? And I mentioned that .NET also has a bytecode concept underneath, and I hope to consolidate, I hope to create this an MDA model that is able to do both, and I think XML will also be of benefit here. We can use some UML tools to help us with that kind of mapping. Yes?
So it strikes me that you handle the case where the browser doesn't have Java in it, What about the case where the browser does have Java in it? Wouldn't it be more efficient to just pass the last file straight through?
The question is, we handle the case where a browser does not have Java, but what if the browser already has Java? Sure, I mean, what you can do is you can probably come up with a little bit of code that can test if you have an appropriate JVM plugin inside that browser, and then alternatively just simply load the class file. You're perfectly right. We haven't done it yet. You know, it wouldn't change the behavior, except it would be a little bit more responsive. I mean, I don't think that you should have any computing intensive business logic inside the browser anyways. So I mean, you might also ask maybe another question that I sometimes get is, isn't that too inefficient? You know, if you take the bytecode, all this pushing and popping. But for the kind of application that we are looking at, I think it's not really a big of a deal. You know, I mean, you shouldn't have like computing intensive things in the browser happening anyways. So I think, you know, for Ajax, for the kind of goal you're trying to achieve with Ajax, yes, you could do that optimization. And you could also think of maybe cross-compiling to ActiveScript if you find a Flash plugin, for example. You know, it might also be a little bit more performant than doing it in JavaScript. But you know, we are academics, we're just trying to get something done, and we don't have the resources for doing all these bells and whistles. I put it on the to-do list. Any other questions? Well, looks like no more questions, so thank you very much again for your attention.